So sad leaving Italy today under the rain. So together with the faculty, we decided to change the schedule in order to let you go with no problem to your destinations. So this morning, as we did already say yesterday, Professor Jäger is gonna have his talk about overview and practical aspect about induced hypothermia. And then the second talk will be Linda's one, Professor De Vries. We're gonna have break at 10:30 as written. And then Roberta with neonatal stroke. Our target would be to stop, at least for the international audience, about 1:30. Okay? The one of you coming from Italy who needs the credits are going to stay here to have the evaluation form. It will take about 30 minutes. We would prefer to try to go straight to the end. Maybe we will be a bit late, about 2 o'clock, but after that you will be free. Okay? See you.
That's okay. No, that's okay.
Do you want to show your presentation?
Yeah. But I'm okay. Yeah. So good morning, everyone. Buongiorno. You can see that I think people have put sort of our emails on the slide here. So if you want to send nasty emails, please don't. But if anybody wants to, I guess, speak with us after the sessions, that would be the way to do it. Certainly, I'm from Canada, so I know it's a long way. And right now it's cold and maybe 1.5 feet of snow, so not so good. This is much better, the rain. But if anybody wants to join me in my lab or come and observe or do anything with the neurology service in Edmonton or Canada, certainly let me know, and I know lots of people, so I can make arrangements across Canada, certainly in other places in North America. Oops. So this will be my last lecture of the session, and I want to thank everyone certainly for being present and coming to the symposium. I hope it's filled your needs and provided you with some information, supported some of the things that you knew already, and perhaps gave you some new ideas as well. It's certainly been a great pleasure for me to be here and to be in Torino. It's a beautiful, beautiful city. And a beautiful country, for sure. Thank you very much for inviting me. So this morning I'm going to talk a little bit about hypothermia as promised, and I thought I'd put this last because it followed a bit better the series of talks that I did previously. So I'll try and give you a bit of historical background about why hypothermia is currently present. What the support is in terms of research and the clinical trials, some of the overview of some of the clinical trials, why we believe hypothermia works, at least in broad terms, and some of the future directions that we'll be undertaking. So the take-home messages, I like to let you know what you should know before the end. So in case you fall asleep, it's all on the slide, or pretty much. Is that hypothermia is really currently the only accepted and proven effective therapy for a hypoxic ischemic injury. And surprisingly enough, the newborn population, or the newborns and pediatrics, is well ahead of the game in terms of what the adults are doing for their hypoxic ischemic injuries or trauma or stroke, because we've adopted hypothermia within the neonatal units for the most part. We do know that it's effective, at least partially, and in spite of the fact that people in the adult world have been working on stroke for many, many years, more than we have in neonatology and pediatrics, we're actually ahead of the game. So we can be, I think, very proud of that, and very proud of how the national and international communities have really worked very well together to bring this not only to clinical trial, but into translational medicine, which is what the buzzwords are nowadays in terms of bringing basic research into the clinical world. So in spite of the fact that we often think pediatrics is behind the 8 ball, this is certainly one area, neonatology is certainly one area where we've been advancing very dramatically, and I think we can all be proud of that on an international level. And it's workshops and symposiums like this that help make that happen. People like Linda DeVries who are at the forefront of making these international collaborations work well. So that's a bit of a plug for all of us. We can all pat ourselves on the back a little bit. But hypothermia, although it's adapted, it's incompletely effective, and we do need to recognize that it's largely targeted towards the term or near-term asphyxiated baby. And as I said yesterday, that's about 15 to 20% of the population if we believe our epidemiologic data. So we still do have a lot of work to do. We can't sit around on our behinds and not do anything further, and there's still lots of room for research and improving things. And in order to do that, we're going to probably have to open our minds to what can we do in the future. And certainly one of those things will be the combination of using hypothermia with other medications or other products in what Donna Ferraro terms as cocktails and ice, which is kind of a nice little term that I've adopted from her, and works really well. And in my mind, I think prevention is one way of also looking at how we can start to address the issues that we face with preterm babies and prematurity. And I spoke to you a little bit about that yesterday. And hypothermia probably has a much broader spectrum than just perinatal asphyxia. And certainly within the clinical trials that have currently been finished, sub-studies are being looked at in terms of the adaptability or accessibility for hypothermia in terms of necrotizing enterocolitis, IVH. Is it a valuable source for treating prematurity? I think we really need to study that before simply adopting it. And as I said yesterday, and I showed you a slide, it may not be. It may actually be something we need to be careful about in terms of inducing hypothermia in a premature baby. Is it something that we can look at for neonatal stroke or perinatal stroke? And the reason that hasn't been really adopted directly at the present time is because we don't diagnose perinatal stroke usually until 12 to 24 hours after it actually happens. And so whether or not delayed hypothermia is effective under those circumstances is still unclear, even though really the Rice-Vanucci model that people have used in the lab to look at hypothermia is in fact a model of perinatal stroke, if one wants to be very specific. So having said that, those are some of the take-home messages from this morning, and hopefully we can get there. It's a very old idea. It started 300 years ago. John Floyer suggested that babies might be better off if they were a little cold after birth. And moderate hypothermia in clinical practice began in the 30s and 40s, particularly when people recognized that near-drowning victims in cold water actually survived a lot better than they did in warm or neutral water. And deep hypothermia became a standard of care neurosurgically and for cardiac surgery around that time as well. But they were taking children down to temperatures of 18 to 20 degrees centigrade, which is a lot cooler than we're doing so in the nursery. And they're still doing that in a more moderate form, not quite down to 18 to 20 degrees, but more in terms of 25 degrees, and still with very significant success. In the newborns, in the 50s and 60s, people began to allow, particularly in preterm babies, and this is why we need to be cautious, they exposed them to cold environments for prolonged periods of time, usually 5 days. So what they would do is allow them to deliver, and they would put them in an incubator and let them stay there for 5 days. And unfortunately, that was recognized as causing an increase in mortality. So more preterm babies actually died when that happened. And there was cardiovascular compromise and coagulation defects in terms of hypercoagulability. So that whole series of studies by Day and I think Long in the 50s and 60s led to the promotion of thermoregulation. Really, so that's why everybody got all excited and said, oh my God, we really have to make sure that these babies stay in a neutral environment and stay normothermic during the course of their time. And it really stayed that way, as you all know, until very recently. And that happened in the late 90s or so. There was, or actually the early 90s, there was a resurrection of mild hypothermia as a neuroprotectant in adult animal models. And this occurred while I was actually doing my training back in Hershey, Pennsylvania. And they recognized that reductions in temperature of about 2 to 4 degrees, so really very mild, you'd not expect that to necessarily do anything, was profoundly neuroprotective, especially when you induced it during the time that the animal was getting the insult of ischemia. And that was all well and good, except we couldn't predict when a baby was getting ischemia because usually that was happening intrapartum. And certainly in adult stroke, you couldn't predict when adults were getting a stroke. So people started to look at it post-ischemically. And that led to the idea that brief post-ischemic hypothermia originally was thought to be very beneficial, but when people looked later on, in fact, it didn't provide any protection at all because the transientness of the protection was lost later on, and it just seemed that hypothermia was delaying the inevitable as opposed to actually permanently reducing damage. So people started to look at prolonged hypothermia, mild hypothermia of 2 to 4 degrees, anywhere from 6 hours to 12 hours to 24 hours in some circumstances. In Canada, they were looking at 48 hours, probably because it's just always winter there. and that certainly showed some degree of permanent effectiveness, and that led to quite a number of hypothermia studies in the newborn, and we started to do that in Hershey. There's been a tremendous amount of work done by Marianne Thorson in the UK, by Alistair Gunn in New Zealand, and a host of others in the United States as well. So I'm going to just show you some of the data that we have, and then we'll move on to clinical trials. So early on, we took a bunch of those lovely little 7-day-old rats, and we put them into water baths in a little jar, and we controlled the temperature of the water bath from 37 degrees, which is felt to be sort of normothermic, which is an entirely different argument, but we'll just say it is for now. And we lowered the temperature during the course of their ischemic insult, so during the time that they were getting a hypoxic ischemic insult. And what we found was that their brain and their body temperature lowered at the same time. And we know that in our own newborn humans, that they're actually poikilothermic as well. And what that means is that under under normothermic circumstances, they can only control their temperatures within about 1.5 degrees. And that's why if you put them into a cold incubator, they actually get cold. They're not like us. If we go outside without a jacket on and into the cold weather, we're going to shiver, we're going to burn off our fat, but we're going to maintain our temperature until it gets so extreme that we have no fat or we can't shiver anymore, and then that's a problem. We become hypothermic. But babies will do that right from the beginning, or babies are unable to do that right from the beginning because they don't really have large stores of brown fat. And that's true of the rat as well. So it's actually a nice little model But humans is the same, and that's why, of course, you control temperatures in the incubator or under the lamps. And when they're asphyxiated, that gets worse. They actually mimic their environmental temperature. So if they're asphyxiated and you put them into a 22-degree room, which is what your normal temperature would be in most hospital rooms, they're going to get very, very cold. So we control them. And that's what gives us all the power, is that control in their physiologic stamina. At any rate, when they're under asphyxiated circumstances, they cool down to their environmental temperature, and then once the asphyxia goes away, both their brain and their core temperature increases and remains poikilothermic for at least 2 or 3 hours. So we have to control that. And we found that when we cooled them during hypoxia ischemia, during the asphyxial event, their amount of brain damage dramatically reduced. It almost went down to zero. If this is normal control, if we cool them down to 34 degrees, it was down to about half of the damage that we saw, and if we cooled them down to 31 degrees, it was well down to about 10 or 15%. So it was hugely effective. But we had to start looking at post-ischemic hypothermia, and many of you will know this, but if we looked at it post-ischemia for brief periods of time, so under these circumstances, it was 3 hours. If we looked early on at the brains of these animals, what we found is that it was protective in the cooler at 31 degrees. It was very protective in the yellow. But if we let the animals grow up, we showed, just like in the adults, that that protection was very transient. It didn't last. So brief periods of hypothermia were really not very effective. They seem to prolong that sort of post-ischemic maybe window of opportunity, but it didn't last forever. So we had to start looking at longer periods of time. And we looked at 12 or 24 hours of hypothermia in the same animal model, the Rice-Fanucci model that I've been talking about a lot in the last few days. And we looked at moderate injury, so an injury that causes moderate brain damage, and a period of ischemia that causes severe brain damage. And this is important because this really does mimic what we, I think, seem to know also in the human to some extent, and that is that with a moderate injury in the sort of SARNAT 2s and some of the 3s, that we do get permanent neuroprotection at mild to moderate hypothermic. But in severe circumstances, with a severe encephalopathy, we really don't see any neuroprotection. And we never see it. We never see it early on, and we never see it later on. And that really quite, I think, mimics what we're seeing from the clinical perspective, which tells me that our model is really quite effective, and we can keep using it as a way of determining some of these therapeutic applications. And this post-ischemic delayed hypothermia has really been, or post-ischemic hypothermia has been mimicked in a number of different species, sorry, wrong slide, in a number of different areas. But whether or not it works, delayed hypothermia is unclear. So if we look at these are various regions of the brain, the cortex, temporal lobe, striatum, and hippocampus. And if we look at early cooling, like almost right after, we see that it is very effective in these light gray lines. If we delay the cooling, it's effective in some areas, like in the striatum and the temporal lobe, but not completely, and not in the hippocampus. And if the cooling is delayed until after a seizure, and this is work done by Alistair Gunn in his sheep model, it really wasn't effective at all. And I'll go back to that, and you may remember my slide from yesterday that showed that if you cool before the seizure, it actually not only reduces the harm, or not only reduces the seizures, but reduces the harm from seizures. If you wait till after a seizure, it really isn't effective. So, you know, that makes a bit of sense when you think about it. It's the cat is already out of the bag. So once the damage is done, it's very difficult to really bring that back. And this has been shown again recently by Pabello, who used the rat model. The earlier model that I just showed you was a sheep model that Alistair Gunn tends to use. And this is, again, the rat model looking at post-ischemic delay. And what they found is if you cool during the time of the injury, you can see that there's really no injury. If you wait, the injury is not really all that well effective. And they used 2 periods of time. They waited an hour. This is their protocol here. So if they waited an hour until after the ischemic event, and the second, their delayed hypothermia was about 5 hours after the event. And what they found was that the early hypothermia was effective, but if they delayed for 5 hours, it was not effective in terms of helping the amount of brain damage. And that's an important concept, and I think actually needs to be repeated a few more times, because it not only talks about, how efficient one has to be in terms of transportation of babies to the unit, in terms of getting the hypothermia, or whether or not we need to establish hypothermia early on for outbound children, but it's also important in terms of whether or not this is an application that can be used for a neonatal stroke, and that Dr. Cilio and Linda will talk about after. But that's extremely important because, again, when we talk about treatments, I think we need to be very specific about what we mean by the treatment and who it is we're treating, under what circumstances we're treating. So if we took hypothermia and said, oh, this is fabulous, let's just use it for everything, I think we might be a little bit disappointed. And I think the way we're doing it now, in fact, is the right way. We're being very specific. We're looking at the term asphyxiated baby. We're imposing hypothermia within a limited period of time, within usually 6 hours. Many centers are trying to do hypothermia at the origin of birth, and that's the way we should be doing it. And we're not throwing the baby out with the bathwater, so to speak. And many labs, including my own, and certainly many in Europe and other places, are now looking specifically at what other applications hypothermia may have within the perinatal brain injury spectrum. So this is just to emphasize that, and this is the slide I showed you yesterday, that hypothermia is really not effective, or pre-ischemic hypothermia is not effective, which kind of makes sense and maybe has application to the premature baby, so I think we need to be careful about that. But hyperthermia was. So again, thermoregulation, very important, but the timing and the duration even more so. So I'm just going to jump quickly to the clinical trials that have been going on. So the background is that, as I tried to show you, that hypothermia is effective, probably not so much or shouldn't be applied to the premature infant. Short periods don't seem to be effective, at least in the animal models. It's not particularly effective, and we can have a discussion about that in the very severe infants, and it doesn't seem to be tremendously effective if we delay for too long. So those are the, I think, sort of 4 or 5 major points that we need to take home. And then this went to clinical trial actually pretty quickly when it comes to sort of the scientific world, but it was done very well, and we all know that there are a couple, or by now I think there are 4 international trials. This is the CoolCap trial, I believe, that was led by the Australian and New Zealand group, and they looked at selective head cooling with mild hypothermia. But these are interesting data because they're now being sort of subcategorized, but it's important to look at. So when they looked at the original data, actually death and disability didn't show any improvement, which I think made everybody go, oh my God, what happened? We just spent a couple $1 million and nothing happened. But when they subcategorized them and looked, because this is the group that did AEG, and looked at those that had abnormal AEGs, they did in fact find improvement in overall outcome in the treatment group versus the control group. And that was the important differentiation of the cold cap trial, the cool cap trial, to the North American trial that looked at whole body cooling. They used the AEEG, as Linda spoke about earlier, and were able to differentiate individuals who are more severely affected or moderately affected than this, and split those groups up, so we actually did see some improvement in those subcategories. This is the whole body hypothermic group, and again, when they looked at death or disability, overall there was a significant improvement, but if you look down this row of other parameters, death individually, not so much, death or disability, not so much, Bailey scores, really not so much. But when you combined all of those things, we tended to see, or there tended to be an improvement. And, sorry, I'm having trouble seeing my own slides here. There we go. I just wanted to point out a few things here. So when they looked at the cerebral palsy, there was an improvement in overall outcome in terms of cerebral palsy. And when they looked at the Bailey mental and psychomotor scores, again, there was an overall improvement in the more severe groups. So that helped because, again, if you look at lumping and splitting, you can throw the baby out with the bathwater. So this kind of statistical sort of view of the overall studies is very important because we now can subcategorize them, and rather than keeping all of them lumped in, which really didn't show any improvement, subcategorizing them into the various encephalopathy scores and the various outcomes was very important. And I think most of us kind of believe that there is actually improvement now, and that certainly they're being used. So these are the studies that have been done over time, and there's now, as you can see, quite a few of them. There was a smaller study that we were involved in Canada, the CoolCap trial, the NIH trial, the TOBY trial that I'll go over. There's an ICE trial, and Dr. Simbrunner was involved in a Euro trial that I'll show you momentarily. And now there have been 3 or 4 systematic reviews of all of these things, so that's sort of looking at all of them put together and trying to find out if there's a common thread and a common outcome that we can all rely on that says, yes, indeed, we should be looking at hypothermia. And so this is one of the first things, again, on the right side of this line is favoring normothermia. On the left side of the line is favoring hypothermia, and you can see that the early trial done by Alistair actually wasn't as happy as he would have liked, I'm sure. But subsequent trials have been by Shankaran and by Gluckman have been on the favorable side. And now that this is including the TOBY trial, that has shown us to favor outcome. And if you look at the combination of things now that we in the systematic review, when we combine all of the things, death or disability is improved, survival with a normal outcome is better, mortality is better, severe disability in survivors is a bit better, and cerebral palsy is a bit better, as well as neuromotor and psychomotor delay. So we're looking at some pretty good improvement. The same thing has been shown by the European group led by George. Again, primary outcomes of death or disability, an improvement, death or severe disability. In their severe group, they did show some improvement, and the others were actually, except for developmental quotient and disabling cerebral palsy. So there's been a very recent systematic review by Tagan, and that was published really in the last month or so, that has looked at all of these now. They've looked at the TOBY trial, the European group, everything. And fortunately, what we see here is that all of them now are favoring hypothermia. And that's an important that's an important commonality within the different groups, and you've probably all seen this, so I'm sure I'm not giving you new information. But the thing I think to take away from this is the consistency that we're seeing now. We're seeing consistency in very large trials internationally in different centers by different methodologies, cool cap versus whole body, that are telling us or indicating to us that hypothermia is effective. They're also telling us that it's predominantly effective within that sort of moderately injured group, with perhaps a bit of leaning towards the severe group, and that there's some consistency. And that's really sort of emphasized in that slide there as well. So I'm not going to go over that. So what kinds of things are people seeing when they're inducing hypothermia? Really, bottom line is it seems to be very safe and done under the right circumstances and with the right controls in place. There really are very few negative side effects. But there are things that one needs to be cautious of. Probably the biggest issue is bradycardia or arrhythmias. Some people have seen some hypotension in some of the children, and as we talked about the other day, these contributing factors are important to monitor and important to maintain within normal parameters. Thrombocytopenia are things that some people thought, but again, the odds ratio or the increased likelihood of those occurring is relatively small compared to bradycardia, which is the big one, and occurred is 7 times more likely to occur in the hypothermia group. The rest, really not so much, even though they're present. So the other thing that's been coming out lately in the literature is what's better? Is it selective head cooling, or is it whole body cooling? And that is, I think, still a little bit controversial, and it depends, I think, to some extent who you talk to for sure and where you live. There was a bit of a, I think, joke going around that was prompted by Steve Miller, who said that if you're in Australia, and where they're doing, I think, selective head cooling, the cortex, you're better off if you've had a cortical injury, and if you're in the States, or I think in the UK where whole body hypercooling is done, you're better off if you've had a basal ganglia insult. So we're probably still working on those things. But certainly both have been used, and this is just a picture taken from one of Terry Inder's papers where she shows basal ganglia insult, and in this one a more cortical watershed kind of insult. And when they looked at some of this data, even though it didn't really reach statistical significance, in the individuals who had severe basal ganglia injury, they were better off having selective head cooling than whole body head cooling from that group. And when Barks looked at their selective series, they didn't look at the whole group of in the clinical trial. They looked at their own group, I believe, and they found abnormal brain MRIs to be more common actually in the selective head cooling group. So again, prompting a bit of controversy. And certainly when they looked at the basal ganglia scores using the Barkovich method, again, they found a little bit worse outcomes or worse MRIs in the individuals who had selective head cooling than those who had whole body cooling. And so there probably are some differences between those two methodologies. I'm not quite sure what you're using here in Torino or what you're adapting to, but those are things to consider. And again, it may be that certain types of injuries are better off with certain types of cooling. So if you have a sentinel event where you're more likely to get a basal ganglia injury, perhaps whole body cooling is the way to go. If you had a systemic insult, like a perinatal asphyxia insult, maybe selective head cooling is the way to go. And I think we're probably going to have to work that out a little bit, because we can probably fine-tune this better. And we all know that you know, it's easy, not easy, but it's not. We can identify sentinel events. I mean, the child who has uterine rupture, or the individual who has a profound fetal bradycardia prior to delivery, we know that that's a sentinel event, and we know that we can look at that. There was some controversy around whether or not MRI remains a predictable biomarker for kids who have undergone hypothermia. And the bottom line from this is that, yes, indeed it is. When they've looked at the basal ganglia scores, it does help. When they've looked at the posterior limb of the internal capsule, it does help. When they've looked at white matter injury, it does help. Where it's been less effective in helping us predict outcome is just looking at cortical injuries. So certainly, again, those injuries that seem to be most severe involving the basal ganglia and deep white matter areas are still probably the most predictive. Utilizing the cortex as a single or isolated way of predicting outcome is perhaps not the best way to go. But what this tells me is that really you have to look at the whole brain, which kind of makes sense, and just be cautious that the areas that seem to maintain predictability are the deep gray matter and white matter areas. So is there a way of predicting hypothermia success? In other words, when you have a baby, they've come out of the case room, they're obviously asphyxiated or having some problems. Is there a way of saying, well, this baby will do okay if we undergo hypothermia? And Jeff Perlman, who is, in my mind, one of the great practical thinkers in the world of neonatal brains, decided to look at that question and decided to look at a whole bunch of parameters. And I suppose what he found was not entirely surprising, but these are all kids who have undergone hypothermia. And what he did find was that the ones that weren't successful in terms of their outcome for hypothermia were the ones that had this must have slipped down, I'm sorry. That red mark is supposed to be under the pH, are the ones that had a pH in the low range of 6.8 to 6.9, as opposed to those that had pHs above 7. So if your pH was in the really quite low range, which again would imply a severe encephalopathy and difficult to control seizures, then you're less likely to do well with hypothermia. So what that says, and again, not really surprising, but gives us another parameter perhaps to use as a biomarker, not only when we're talking to parents, but also when we're deciding which groups might be most applicable to hypothermia, or which groups we're going to look at in terms of adding new medication or alternate medication. These are things that we can use to guide us and to selectively use hypothermia so it's very patient-oriented. So the ones that have severe encephalopathy, we know now, using this parameter and what we know from the clinical trials, is not going to, are perhaps not going to gain as much benefit as those who are in the moderate group of asphyxia. And John Barks, again, looked at a group of individuals from their group, and they looked at sentinel events. So these are individuals who had a sentinel event, uterine rupture or profound fetal bradycardia at the time of injury. And again, not surprisingly, this is perhaps not rocket science and is a bit intuitive, but we now have some evidence based on this work that says individuals who've had a sentinel event are probably not as likely to do well as individuals who have not had a sentinel event and perinatal asphyxia. So it's another layer of things that tell me anyway, and hopefully the rest of us, that those individuals who have profound asphyxia, who have deep gray matter structure abnormalities, who are their severe encephalopathic babies, are probably not going to do as well with hypothermia as the others. And if we take this group out, and I'm not saying we should, but if we did that, probably hypothermia would look a lot better in just the moderate encephalopathic groups. But it also tells us this is the direction we should be heading in. In other words, which baby should we be looking at to help the most, or to help better than just hypothermia? It's probably this group, the severe encephalopathic groups. And this is just giving us more evidence that's consistent with what we already know. And that may seem redundant in some ways, and it may seem a little bit intuitive, but it's, in my opinion, very important from a research perspective and from a perspective of looking forward. So hypothermia, after all of that, yes, it is effective. More complete in the moderate group of ischemic individuals than in the severe groups, for sure. And we now have some, I think, good substantive evidence for that. Still some questions, as I said, regarding the severe group. And it's definitely sort of reaching, I think, a standard of care in North America and Europe. And the things that are holding most centers back, quite honestly, is probably economics more than anything else, as we all struggle with that, I know. And even I was talking to Michael Johnson at one of the conferences I was at, and they've developed, this is really cool, they've developed they got together with their engineers. I hope I'm not letting the cat out of the bag, but he told it in open forum. So they've developed a clay incubator, essentially, that you can cool with water pipes to be used in far-off places or developing countries, that cost them about $20 each to make because they're clay, and they maintain temperatures very solidly. So this is, I think, amazing and smart and simple. And so they're looking at ways to clinically trial them and make them for developing countries and sort of remote areas like northern Canada, where they can be used cheaply. And so I think this is something that has the potential for sure to be adopted in many places around the world. So this is back to that old slide. I'm going to probably have to make a new slide, but I don't want to make it more complicated than this because my brain doesn't work that well. So why does hypothermia work? And I think the bottom line is that we think it works because it covers everything. If you make a baby cool, you're kind of slowing down that whole system. Now, I know that seems intuitive and it reduces all the metabolic effects and maybe a bit, well, I'm sure it is a bit too simplistically minded. But in fact, when we look back at what works in the clinic and even what, aside from what works in the animal lab, what really works in humans, it's this kind of stuff. It's stuff that either happens before the injury occurs or stuff that has a very broad spectrum, a very holistic, if I can use that word, approach to the injury, and not something that necessarily just targets this. Because whoever made us was smart enough to recognize that there are about 1,000 different ways to get around this. So if we try and use a silver bullet, it almost never seems to work. We need to think broadly. We need to think how to either prevent the injury or have a very broad scope of approaches to all of that cycle of events. So having said that, I'm just going to jump to what we do know and what has happened in the lab, and I won't spend a lot of time here. This is the work I showed you a bit yesterday with the protection on seizures, so that's all very nice. But what we do know is that it certainly does dampen the inflammatory response, and this is work that was done on, I actually forget who did this work, but it was done looking at caspase or tunnel cells and before inflammatory cells, and again, cooling either, at least under these circumstances, for 2 hours after or 6 hours reduced the effect of ischemia on the inflammatory response and on tunnel or apoptotic changes. And if we look at energy metabolism, this is work done this is work done by the Thorstensen group, and this is work done by our group. And what we found here in piglets is that they actually found that the hypothermia seemed to enhance or the recovery of ATP. We actually did not find that. So these are different and this is in a neonatal rat, we didn't find that ATP recovered better under hypothermic circumstances than not. But what we did find was, and that's really controversial, there are different groups that have found different things in different models. So the whole ATP recovery or loss or secondary energy failure is still, I think, very controversial. Some groups have found that it is effective, other groups that have found that it's not effective. What has been consistent is some of the effects on the inflammatory responses and, of course, overall outcome. But this is work that we did on inflammation and cytokine work, and these are just a couple of slides on IL-1, TNF-alpha, and IL-10. And what we find here was interesting. So on IL-1 and TNF-alpha, which are pro-inflammatory markers, the hypothermia actually had a dampening effect. In other words, it reduced those inflammatory markers. But interestingly, IL-10 is a pro or an anti-inflammatory marker. It's an anti-inflammatory cytokine. And surprisingly, it didn't dampen that. It actually enhanced the anti-inflammatory cytokine. So rather than having a dampening effect on anti-inflammation, it actually has a positive effect on anti-inflammation and a dampening effect on the pro-inflammation. So we're looking at that a little bit more closely and looking at apoptosis. And this is work that we've done with Ran Askelan in Toronto, and we looked at fluorojade staining in the core and the penumbra, because we're trying to tease out, how do we approach this severe group of encephalopathic babies and trying to add something to hypothermia just in that group. And we wanted to know what's the difference between the core and the penumbra under hypothermic circumstances, or is there a difference? In other words, does hypothermia affect the core at all, or just the penumbra, or both, or neither? What does it do? And so we looked at that, and indeed hypothermia dampens both. You can see that there is a dramatic difference in the core and the penumbra dying cells. And when we look at the percentage of tunnel staining cells, again, they're reduced in the hypothermic group compared to the control group, not surprisingly. And when we look at the core and the penumbra, they're also reduced in the core and the penumbra of the hypothermic group. So tunnel staining or apoptotic cells are being reduced in both. And when we look at apoptotic inducing factor, we also see that it's reduced predominantly in both the core and the penumbra. So whereas before we thought, the core was kind of, you couldn't do anything about that. What was done was done. We now recognize that there's a spectrum and apoptosis occurs in both, and maybe we can approach both of those things, telling me anyway that we do have an opportunity to affect these severely injured babies, and it's not just a done deal, and there's no way that we can do anything about that. And importantly, when we looked at so apoptosis was again just this is just a slide in graphic form showing that things are reduced under those circumstances. And this is, this is ZIAP. This is X-linked apoptotic inhibitories of apoptosis. So it has a pro effect on inhibiting apoptosis, certainly in the core and in the penumbra as well. And this is important because not only does it show to enhance anti-inflammatory markers and cytokines, but it's also showing that hypothermia enhances an anti-apoptotic marker as well. And ZIAP, which is an X-linked inhibitor of apoptosis, may also have something to do with the differences in sex that we find. So we also find that males and females that I tried to show you the other day are different. ZIAP is one of these pathways that are believed to be involved in that sex differentiation. So there may in fact be a difference in males and females when we use hypothermia that we haven't elicited yet, and this may be the pathway both through AIF and through ZIAP that we're able to differentiate those things. Okay, so I'm just going to quickly again move on here. Sorry for being a bit long. This is some recent data from the NIH group looking at long-term outcome. So these are individuals who are now 6 or 7 years old. It's about half of the group that they originally started with. They don't have follow-up on all of their information. But again, importantly, what you can see here is that death or an IQ score of less than 7 is, it's trending towards reach significance. It's, just there, and depending on how meticulous you are about p-values and significance, if you're a statistician, you don't like a 0.06, you'd rather see a 0.05, but we can give them a break, I think, and say that there's certainly a strong trend. If you look down, death or disability, if you break it down, are improved. Death with an IQ score of less than 55 is actually improved, and death or cerebral palsy is improved as well. So what that tells us is, like we showed in the animal models, that this is now a prolonged effect. This is not just short-term, but we're actually seeing a prolonged effect in those individuals in terms of death or disability. And the other important thing to indicate about that work was that it didn't tell us that the severe encephalopathics actually didn't die, but there wasn't an increase in cerebral palsy or severe disability, which was what everybody was a little bit worried about. So Dr. Cilio, who is sitting in our audience, did a nice little review with Donna Ferraro looking at synergistic neuroprotective therapies. And really, I'm pointing this out because it's a very nice review, but this is the way we have to go. So this is going to be cocktails and ice, and I'm just going to point to a few things. And I know this is a bit long, so sorry. But luckily for you, it's my last one. So we did a little bit of a study early on looking at a whole bunch of different drugs in combination with hypothermia, and we found that actually allopurinol and glutathione, which is one of the endogenous antioxidant agents, were effective in addition to hypothermia in reducing brain damage in our little neonatal rats, whereas desferoxamine wasn't, flunarizine, which is a calcium channel blocker, wasn't, and actually in our hands, N-acetylcysteine wasn't either. But people have looked at a few different things. John Barks and Feinstein have looked at phenobarbital for a period of time. This is one of their early studies, and they found that when they looked at phenobarbital in addition to hypothermia, pathologically, they found an improvement with the use of phenobarbital in addition to hypothermia. Now, again, these are animal models. This is a 7-day-old rat pup model. They found an improvement in overall behavior using hypothermia in addition to phenobarbital. But when they looked at a brief clinic, or when they did a retrospective review of their babies who have undergone hypothermia and had been on phenobarbital, they actually didn't find that effect to be the case. And they found, if you look closely here, that those individuals, and these are kids that actually receive phenobarbital before they got the hypothermia. So these are kids that often would seize early. That was one of the indications that they were obviously asphyxiated or in a stage 2 or stage 3 SARNAT score. They received phenobarbital and hypothermia either almost simultaneously or phenobarbital before. And actually that group of kids, at least according to MRIs, did worse than the kids who didn't get phenobarbital. So again, a bit of a mismatch between the animal studies and what we're finding clinically, and it's a word of caution. People have looked at other anticonvulsants, including topiramate, and in the animal studies, again, positive effect of topiramate in the amount of behavioral response and in the amount of damage that is seen. And certainly some people have looked at safety and found it to be quite safe. So lots of work in the animal world that is showing that other medications, particularly anticonvulsants, phenobarbital, topiramate, and in these circumstances, Marianne Thorstenson has looked at xenon. Again, a very profound effect on improving damage in combination with hypothermia and even with different temperatures and behaviorally as well. And this is published in 2008. A very strong effect of N-acetylcysteine pathologically, again in combination with hypothermia. This group is Singh's group and Dorothea Jenkins. They looked at hypothermia in combination with N-acetylcysteine and found a profound effect of improvement over and above what they found with just hypothermia alone, both pathologically and behaviorally as well. And I mean, those are very strong data, but we have to be cautious again, because when we look at the clinical world, those don't always match up. And so how are we using these things? I'm going to go quickly. Caspase inhibition, same kind of thing. But what I want to jump to here, because I know it's getting late here, so is erythropoietin, because this is the hot thing on the market, and certainly the U.S. group is pushing this very dramatically. But this is work done by two groups. One is the Ferraro group, and the other is, I think, a Chinese group, the Fan group and Ferraro's group. And they looked at hypothermia in combination with EPO. And this is just, if you focus just on this stuff up here, which is the pathology, what you find is this is hypoxia-ischemia and hypothermia. This is hypoxia-ischemia and EPO alone. This is hypoxia-ischemia in combination. And it doesn't take too much to see that there really isn't an improvement over hypothermia alone when you're adding EPO to that. And they found that both in the Chinese group, and they also actually found that with Donna Ferraro's group. Even though there was an improvement with hypothermia alone, there really wasn't that much of an improvement when you added EPO to it. And in this particular circumstance, they didn't even find an improvement with EPO alone. So one group has actually looked at an in vitro model of using stem cells in combination with hypothermia. And this is just published the other week, actually. And they actually found an improvement. So they looked at oxygen glucose deprivation in a cell culture. That's OGD, is oxygen glucose deprivation, under normothermic circumstances, under moderate hypothermia, and under severe hypothermia. And if you look down here, so severe hypothermia would be 25 degrees, moderate hypothermia is 34 degrees, and 37 degrees is normothermic. And this is mitochondrial activity on the left, and this is cell viability on the left in this slide. So this is an indication of energy activity, and this is an indication as to whether or not the cells survived. And on the extreme right, you can see that this is how the control animals did with just oxygen glucose deprivation. If you look at hypothermia alone, or severe hypothermia, it actually made things worse. There was less mitochondrial activity, less cell viability significantly, and adding stem cells really didn't change that. It still made things, or it didn't improve the outcome. But when they looked at moderate hypothermia, there was an improvement using hypothermia, and there was an additional improvement significantly using stem cells as well. So again, this tells me a couple of things. One is that, again, there's some preclinical, very preclinical in vitro data that suggests stem cells might be effective, but it also tells us that we need to be cautious about the type of hypothermia we're using, because in this circumstance it made it worse, and when we're going to be utilizing this stuff. So I think I might jump over this very quickly. Again, Sitha looked at the MRI scans in their follow-up groups of individuals to figure out whether or not MRI was still a predictable aspect, and they did find that to be the case when they looked at, again, white matter areas. But they also found that if they looked at watershed injury, those individuals seem to be predictive, and there was more strokes in the control group than in the hypothermia group. So there was a shift to the left in terms of overall outcome. I put this in for Nick, actually. There's been a recent study looking at what parents feel about this, and I thought this was really interesting. They did focus groups on parents who chose hypothermia versus non-hypothermia, and it's kind of interesting because what they found, and this is sort of the key here, is that when the child came out of hypothermia, if you read this paper, what they say, and focus group work is very different than sort of basic science or even clinical research, because it's about dialogue, and understanding the dialogue and interpreting the dialogue is a whole different methodology than I'm used to, certainly, and than most of us, I think, are used to. But what they found was that the parents felt that the child looked like dead when it was under hypothermia because it's cool, it's often pale, usually not moving or under sedation. And when the child came out of hypothermia, they almost felt it was a rebirth. And there was actually a very positive feeling about all of that, and that there was like a second chance and things were really doing well. So that choice that they made turned out to be a positive event for them. Okay, I'm going to sort of end off. So, what future questions do we have? Cocktails and ice, certainly. Is delayed hypothermia in the newborn effective? We're not entirely sure. There's certainly some early evidence to suggest maybe not so much. Can hypothermia be used in neonatal stroke? And those two questions are going to be linked. Can hypothermia be used for other injury? I think that's very important. Meningitis, sepsis, certainly necrotizing enterocolitis. And what about premature infants? What are we going to do about this group? And there's certainly some early evidence, at least in my mind, in the animal world, that suggests that, that may not be the way to go with the premature infant, and we may be putting them at risk. Can it be used for the late preterm infant? That's another new population that's really coming up that I think everybody has kind of neglected a little bit, thinking, yeah, well, they're close to term. It's like being, close to an adult when you're adolescent to 16 and you think, yeah, they're close to an adult, they can make an adult decision, and then they go drunk driving, and you realize that, oh, maybe not so much, maybe they're not quite that mature. So we need to think of this group of individuals, the late preterm, as really a separate population, and maybe they're not as mature as we think they are. And that's a group that we're going to have to think about, the 32 to 34 week or 36-week babies who are not quite there yet. What can we conclude from all of this? Definitely hypothermia, it has a role to play, it will play a role. It's not going to go anywhere, and it shouldn't go anywhere. It should progress. Brief hypothermia, only provides transient neuroprotection. Prolonged hypothermia is what we need to stay at, and certainly in the moderate encephalopathy groups. And we need to figure out what to do with the severe encephalopathy groups, and probably looking at additional therapies to hypothermia is important. It's safe. Its neuroprotection is not complete, as we pointed out here, and it is only directed towards that term population of babies that we know about. Are there differences between whole body cooling and selective cooling of the brain? There probably are, and we may need to be a bit more specific as we work through those issues. So, to conclude my sort of 4 presentations in the last couple of days, these are some of my take-home messages. Not surprisingly, this is a really complex area of investigation. And, we're certainly made amazing advances, I think, during the course of my career in the last 20 years, and that's just becoming exponentially growing to the extent that, we now know what causes this injury. We know that there are different mechanisms involved in different injuries. We know that we have to approach these children differently and be very patient-specific in my mind. Hypothermia, just to really beat this down, is important. In term infants, whole brain versus selective, whole body versus selective, important. In complete cocktails and ice, again, only a select portion of the population is being important. I think we need to start to think about prevention, especially for those premature babies. We need to think about the mother and the fetus as being a unit. How do we treat that unit? And how do we try and prevent not only prematurity, but once that premature baby is born, how do we prepare them for that harsh environment that they go into in the nursery? And do some of the simple things. Remember what your grandmother told you. Like this, to me, that's the kind of as I get older, that's the most important thing. You always go back and you say, yeah, maybe they were right after all. So follow our grandmother's golden rules. Dress appropriately, thermoregulation. Maintain your nutrition. Make sure you get lots of glucose. Not too much, not too little. Everything in moderation. Maintain your stability, your physiologic stability. Make sure that when you're looking after your babies, they're physiologically stable, whether it's nutrition, temperature, blood pressure. All of those things are very, very important. They seem simple, but they probably make the biggest difference. And eat your fruits and vegetables, and we'll all be healthy and live for a very long time. So thank you very much, and this has been a wonderful experience. I'm really honored to have been asked to be here and to speak, and I hope you've learned something from a few of the talks that I've given. And again, thank you. I'm humbled. Thanks. Oh, sorry. Are there any questions?
I have a question.
Yes, yes.
You talked about the differences between whole body cooling and selective head cooling. Yes. Apart from the costs, why couldn't we combine them?
Oh, that's a really good question. I don't know why we couldn't. It actually makes a lot of sense to do that, because then you're really getting both things. Partly because I suppose there hasn't been any evidence to support both, but there doesn't seem to be much reason not to do that. It seems to be quite safe. I think controlling temperatures might be a little bit more difficult, because if you're using 2 different systems, then you're obviously complicating how you control that.
You measure the core temperature, don't you? We measure rectal temperatures. So.
You do measure core temperatures, but if you're using 2 systems, coordinating those might be more difficult to sort of balance the 2 more than anything. I'm not saying it's impossible. I'm just saying that you'd have to be aware of that to some extent. I don't think that that's a bad idea at all.
Can I ask a second question?
And maybe, in fact, that's the way to get around the question of, who do you treat with what?
Right.
Again, like my sort of approach is always to provoke a question, not necessarily to answer it, unfortunately. But I'm, what I guess I'm saying in that is that there's probably a select group that will do better with whole body cooling than the other way around, and maybe that's the sort of sentinel group, and we can tease that group out. But combining the therapies will be much more sort of holistic, and I'm not sure that question has been really asked, and certainly not answered, but it's a good one.
Can I ask a second question?
Mm-hmm.
In your rat models, you show that having a mild hyperthermia before the insult
Mm-hmm.
was sort of protective.
Mm-hmm.
In our babies,
Mm-hmm.
we try after birth we try to avoid hyperthermia.
Mm-hmm.
And could you, before we start the cooling, could you comment about this?
About that? Well, that's not the only sort of evidence that preheating is actually helpful. There are other stressors that people have used to kind of induce protection, and I'm blocking on the name of that right now, but people have used other inducers like pre-ischemia, for example, preheating to induce, really to kind of set off the system, the body's own system, to self-protect. That's the sort of underlying theme. Now, whether or not we should actively preheat is a bit of a tougher question. I guess what I would say is I would try and keep the baby at least normothermic before going into your cooling, for a couple of reasons. One is, it seems to me cooling beforehand is not a good idea, but you're not going to cool beforehand. And don't forget, the babies that you're bringing out they're not preheated. It's sort of you're not pre-cooling or preheating because the insult has already occurred, right? So that would be more about premature infants. So in your circumstance where you have an asphyxiated baby that's either an outborn or an inborn that you're considering cooling, the injury has already occurred. So don't heat those babies. And under those circumstances, cooling is better. In the preterm baby, though, that's where we need to start asking those questions, I think, because that's where we don't know when the injury is occurring. And is there a way of, anticipating that or helping that baby fight off the traumas that it's going to face? That's sort of an indication of where to do that.
I have two questions for you.
Mm-hmm.
And before that, just to give some food for your thought, there's on the market a new device where you can choose two different temperatures, one for the whole body cooling and the other one for the selective. So one device, two different temperatures, to give you an idea.
Or maybe the same temperature, but for the body and for the head.
If you choose that,
Yeah.
it's an option. But I would like you to spend some more words about allopurinolo, or maybe asking to Professor De Vries if she would add something about allopurinolo if treating a mother with earth fetal rate not reassuring one, because as far as I know there's a good trial on that. And also if she would add something about melatonin, because there's a trial ongoing at Great Ormond Street, and no side effects. Interesting molecules.
There are actually a couple of reasonably large clinical trials going on. I know that there's an allopurinol trial going, and melatonin is happening as well. It's a bit difficult to comment on what we think the outcome of those would be. I think the very important things that we need to do preclinically, like in the animal models, is definitely show that it helps. I mean, showing that it doesn't help, nobody's going to go anywhere with that. So if they work in the animal models, that's very good. The mistake we can't make is to say that just because it works in the animal models, it's going to work in the human. So what we need to do, and I think what has been done, is to recognize that what we're using is safe and at least effective in the animal model. What I don't think has been done, quite honestly, is ensure that some of the things that we're giving is entirely safe to the normal fetus. Because once we start to treat the mother, we generally speaking don't know if there's going to be an injury. So that's where I struggle quite a bit. If we pick a group of individuals or a group of pregnant women where there's a clear risk to the baby, so like preeclampsia or fetal growth restriction, where we can kind of predict that that baby's at risk for cerebral palsy, then I feel a little bit better about using a medication that we haven't fully analyzed in a normal fetus. If we just take all comers, I'm a bit worried about that because we don't know, most of the babies will be normal. So we have to be really sure that we're not going to be causing any injury. And that's where I think we're not entirely sure. And especially if we're starting to treat these mums sort of in the last trimester, that's a big issue. The clinical trials, to my knowledge, and maybe Linda can speak more about this, are looking more in the last week of treatment. They're not looking at the last trimester. The prevention that I was talking about yesterday, like with, you know, pomegranate juice and all of that, I would consider treating in the last trimester at least. But so those are the questions I think we need to be very, very clear about, is identifying the group, the cohort that we're going to deal with. And in my opinion, with those medications in the last week or so, we should look at a high-risk group before we do anything else. Linda, do you have any more information about some of those trials, or the allopurinol group or the melatonin group?
Well, I actually haven't been involved myself, but Frank van Bel has done this antenatal allopurinol study.
Yes.
Based on the CTG, the STEN. And what they found was that there was a significant decrease in S100B, but only in the females and not in the males.
Yeah.
And the thing was that hardly any of these children did develop severe or moderate HIE, so they were hardly ever admitted to our NICU. And they did have some kind of mild perinatal asphyxia, but not moderate to severe.
Sounds good. Thank you.
Thank you for your lecture. I would like you to comment, if possible, on clinical trials, ongoing clinical trials concerning different temperatures and different quite late hypothermia between 6 and 12 hours at the onset of hypothermia. Are you aware of those trials and any results?
I'm actually not aware of any trials that are looking at briefer periods of hypothermia or
starting late.
Starting late, yeah.
After 6 hours. I think in the United States there are some groups that are recruiting those that arrive a little bit late, after 6 hours, and starting hypothermia only after 6 hours.
I think that
maintaining normothermia until after 6 hours.
actually, I'm personally not aware of it. Maybe I'm not aware of any of those trials. I think that they may be looking at some of that data where hypothermia may have been started a bit late for reasons that are for transport reasons. Do you have some information about that?
No, it's exactly like this. So it's not that they are waiting until after the 6 hours to start hypothermia.
Yeah.
It's that some groups are anecdotically cooling babies that arrive after 6 hours, but most of them, they had passive cooling before. So and as UCSF also, some of them, very, very little number, because we really try to cool to start the active cooling within the 6 hours.
Yeah.
But there are more babies, most of them, they have been on passive cooling after birth, and they just arrived at the cooling center late.
I think so there are no approved clinical trials that are looking at that. As Roberta said, I think people are looking at some of their retrospective data. And that study, with all due respect, is probably not going to happen, because ethically it's going to be very difficult to randomize to early cooling versus late cooling. So I think what will more likely happen is that in those circumstances where individuals are not able to cool until after 6 hours, if that data is collected and then accumulated amongst various centers, we can get some information about that. I think most of that late cooling data is going to have to come from animal work, et cetera, and looking at a very specific group, which is probably the neonatal stroke group. I think more of the direction is going to go into hypothermia plus and looking at the severe encephalopathic groups as a very isolated group of individuals, because they're clearly, in my mind anyway, separating themselves out from the rest of the group as the ones that are really not getting any benefit or very little benefit from hypothermia. So how are we going to address that? And part of the issue, I think, that's happening is hypothermia, in animal models does a really good job. Like if you cool down a baby rat or a baby piglet, you're doing a really good job. You're reducing the injury by half or more. So adding to that, like making it even more than that, is quite a feat. So I think that's part of the reason why the erythropoietin plus hypothermia in the preclinical trial may not show that much effect, because you need very large numbers and you need a very big effect, and so whether or not it's going to be very difficult to show that. And so again, we may need to not just look at the moderate, or not lump the babies, even the rat babies, but look at them in isolation. Which ones are severely affected, and did hypothermia do anything for that, or combination therapy do anything for that in an isolated way?
Dr. Jäger, could I just?
Yeah, whoever wants to.
Just a moment.
Can I just rephrase my question, ask you, in practice, what would you do? I don't know if in Canada it is usual to get that, but if you have a baby that is unable to reach the NICU, the cooling center, before 6 hours, and if you get a baby that is at a normal temperature at 7 hours,
what do I do?
What would you do? Yes.
Fortunately, I don't have to make that decision because I'm a neurologist and they don't ask me. But I think what is happening now, so if I had a choice, and I hate to do that because I'm on record, I'm being taped, I think, but I would probably cool if it's at least within reasonable parameters, not like way out to 24 hours or anything. But I think what is practically happening is that those outborn babies, particularly if they're way up north, like Roberta said, they're either being passively cooled or they're being asked to put like ice packs around the babies to cool them down before they get down to the unit. And then they're monitoring their temperatures as they're being transported. So I don't think we're going to be having to make those decisions, because fortunately ice is reasonably easy to come by, at least in North America and Europe. And so I think what's going to start happening is that the outborns are going to be passively cooled or actively cooled with ice packs before they get down to the tertiary care centers and the level 3 centers where they can be monitored a little bit more closely. So I think practically speaking, that's what my recommendations would be to outborn babies.
Dr. Jäger, if coagulopathy and thrombocytopenia is a side effect of cooling, is there an animal model where they've looked at birth trauma with cerebral bleeding and cooling?
With
if
animal model,
cerebral bleeding from trauma,
cerebral bleeding,
birth trauma, yes, with bleeding,
yeah,
and you got bleeding
and cooling,
Has this been looked at?
Not in the newborn, but there are quite a number of of studies done in the adult rat population, in particular, looking at intracranial hemorrhage and cooling, and it actually has no effect, even in the rats. So people are looking at that more closely, but it's a bit of a different phenomena. Like bleeding into the brain is quite a bit different than ischemia of the brain. Because bleeding, especially like if it's, and I think like Linda showed the other day, is if you have a bleed into the ventricle or a bleed into the brain, you're really kind of pushing things aside. So it has a very different effect than ischemia does. And at least in the animal models where they've looked at hemorrhage and cooling, it has not been effective. Yeah.
I have two questions for you. One is the role of cooling in labor room. You know a child has had a sentinel event and you're resuscitating in the labor room. You know, there's, when you say resuscitation, a lot about temperature, keep the temperatures normal. But in this case, would you start the cooling straight off, is my first question. And the second one is, what is the role of hypothermia? Are there any studies or something out there for a child who's maybe 2 days or 10 days or 15 days old, comes with a cardiac arrest in the ER? Is there a role of hypothermia in those kids?
Yeah. So in answer to your first question about the sentinel event, I would cool, but mildly. Just follow the same parameters that you would do in the nursery, but start it as early as you can, as long as the event has occurred. Right? So, yeah, I would do that. In terms of cardiac arrest and outcome, that's a sort of a different scenario, but there have been studies that have been done, both in trauma, at least in kids, and with cardiac arrest. And again, I think this really speaks to the issue of patient selectivity. So one shoe doesn't fit everybody. In the trauma world, where kids have been traumatized or car accidents or things like that, Jamie Hutchinson did a big, at least cross-Canada trial, and actually didn't find any improvement with trauma. They're re-looking at that data because the severities of trauma were quite a bit different, but overall they didn't find any improvement. In the cardiac arrest data, and I haven't updated myself all that recently, but I believe there is an improvement if you're looking at cardiac arrest, because it's an ischemic event as opposed to a traumatic event, and that's where at least hypothermia seems to play a stronger role a stronger role. So there is improvement with cardiac arrest, not so much with trauma.
I was wondering if any one of you working in North America was aware of a clinical trial, longer and deeper. The deeper branch, it means target temperature lower than 33, seems to be not so interesting, but the longer seems to be very interesting. Not 72 hours, 96 hours of hypothermia, especially for the severe one.
Mm-hmm. Again, I'm really not aware of any clinical trial that's going on in that regard. I think there's a bit of concern about, because when we look back at the 50s, 60s data and they found that cooling the babies, caused an increase in mortality, and people, I think, were starting to see some increased side effects with prolonged cooling in terms of coagulation and bradycardia and things like that. There's a bit of worry that the longer you keep these babies cooled, especially if it's another 24 or 48 hours, you're going to start to see much more side effects. And so I don't think that's the way things are going, to be honest with you. I think really there's a real push towards adding other therapies to hypothermia. I think the idea of either prolonging it or deepening it or delaying it, we're probably done with that. I think ethically it's going to be very hard to move in that direction. So it's more about adding things to hypothermia. And I think that's the wise thing to do, to be honest. I don't think beating this area up is a good idea. We know it works. Stay with that and then add things to it. Excellent. Well, thank you very much. And I'll... enjoy the rest of your morning. Unfortunately, I have to catch a flight, but this has been a real honor, and thank you for inviting me.